Hi guys, so today we're talking about binary numbers, all right? So in mathematics, you need to know, and not just mathematics, but for the purpose of this teaching, mathematics, there are different number systems, okay? We have the denary number systems that operate a 10 number 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we have the binary numbers. What are binary numbers? They are numbers that uses just zeros and one. So whenever you see any number like this, most likely it is a binary. All right, so let's see how we do. So now our base 10 numbers, we have like I said, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are my base 10 numbers. So whenever any of the combination of this number or even the number standing alone, you call them base 10. So if I pick any number here randomly, I say 7 and 5, right? That's 75. That's a base 10. Even if I do not say 75 base 10. All right, so now let's convert. I said conversion of base 10 to base 2, right? So in number, your number 1, that's 1 base 10. How do I know what it gives me in binary? This is my denary numbers and binary numbers. Bi means 2, don't forget. So I go 1, right? Because it's a binary number, I'm going to be dividing with 2, or rather, dividing by 2. Good. So 2. How many times, and worthy of note, right? Worthy of note that binary system uses remainders to form its number. All right. So how many times will I get 1? Will I get 2 from this one marker? 2 in 1. That's what it means. How many times? It's impossible. So you say 0 remainder. What is remaining? It's still remaining 1. Do you understand? Okay, I'll go again. This is a marker, right? How I can't get 2 from one thing. That's why I said 0. Since it's 0, can I continue with my life? So I say remainder 1. So that's how I got it. So, and then don't forget I said it's the remainder we use in binary. That means what do we have here? Just 1, then 1. So 1 base 10 is the same thing as 1 base 2. Do you understand that? All right. So let's move on to the next. So we'll go for 2 and 3 before we proceed further. 2, 2. How many times will I get 2 from 2? 2 divided by 2 is 1, remainder 0. And every time that there's 1 here, you can still proceed until there's a 0. 2 in 1, we just established now that it's impossible. Impossible means 0, remainder 1. Every time you're doing binary, you go from the bottom to the top. What do I mean by that? The arrow goes like this. So you take this one first, equals to 1 and 0. So 2 in base 10 is what? 10 in base 2. Do you understand that? Okay, now we'll go further. We'll go further. We're going for 3, right? 3. I want to use 2. How many times am I going to get 2? A group of 2 from 3. Just how many times? 1, 2, 1. 1. Remainder 1. I said that every time there's a 1 here, you still use 2 to divide. So 2 in 1 will get 0, remainder 1. Until you get a 0, remainder 1 for all numbers, you do not stop. Don't forget that. Then we go from the top to the bottom. What do we have here? 1 and 1. So 3 in base 10 or your binary number system gives you what? 11 in binary. Do you understand that? All right, so now let's go to any other number. Let's pick a number. Let's say do 2-digit number. Let's say 19, right? Okay, so 19. I want to know what 19 is in binary. I divide by 2 always, anytime I'm getting a binary. 2 in 19. when you do your multiplication table, which is closer to 19, because this is not an even number, so 2 cannot go, it's going to remain 2 in 19, 9, remainder 1. If you want to confirm if you're right, 2 multiplied by 9, 18, plus 1, 19. All right, that's if you want to check your progression. As you progress, you want to check something. All right, now 2 in 9, 4, remainder what? 1. If you want to check if you're correct, 2 times 4, 8, plus 1, 9. You got it. All right, we're still not having 0. Until we have 0 here, we do not stop. 2 in 4, 2, remainder 0. All right, 2 in 2, 1, remainder 0. Don't forget, until you get a 0, you do not stop. 2 in 1, 0, remainder 1. You go from the top, from the bottom to the top, and we have 1, 0, 0, 1, 1. So we have 19 in base 10 as 1, 0, 0, 1, 1. So now let's do a 3-digit number. Let's do a 3 digits. Let's say, for example, 101 or even 100. It could be any of it. That's the truth. It could be any of it. So we want to check, how do I write 100 in binary without writing it in binary? 2 in 10, 5. 2 in 0, 0. Remainder 0. 2 in 5, 2. Remainder 1. 2 in 10, 5. Remainder 0. 2 in 2, 1. 2 in 5, 2. Remainder 1. Okay? The reason why the remainder here, we do not just say remainder, is because there's still a number here. But here there's no other number. Alright? 2 in 12, 6. Remainder 0. 2 in 6, 3. Remainder 0. 2 in 3, 1. Remainder what? 1. 2 in 1, 0. Remainder 1. Until you get a 0 remainder 1, you do not stop. So 1. So you go from the bottom to the top, and that leaves us with 1, 1, 0, 0, 1, 0, 0. So 100 gives us 1, 1, 0, 0, 1, 0, 0. All right. So that's that. Do you understand that? Do you understand? Okay. So okay. All right. So now this for, let's say this is A. Now let's convert back. Let's say we have a number and we will need to convert back. Okay. All right. So conversion of base 2 to base 10. Conversion of base 2, that means you have a binary number and you are curious, or rather curious. You want to know, what is this number in binary? Then you go, let's say for example, we have number, don't forget binaries are numbers that operate with just zeros and one. Let's say 00101, a number, base 2, right? We want to convert. The first thing you need to do, this is quite different from the other one. The first thing you need to do here is, since it's 2, don't forget when we were converting to base 2, we divided by 2. Now that we're converting to base 10, we would multiply by 2 individually. So let's go for this one. We say 1 multiplied by 2 plus, what is this? 0 multiplied by 2, right? Sorry. Plus, what is this again? 0 multiplied by 2 plus 1 multiplied by 2 plus 0 multiplied by 2 plus 1 multiplied by 2. Now this is the first step, okay? By picking each of the binary numbers and multiplying it by 2. That is the first step. The second step is that you are going to start from your right hand side, the last number here. And then on the 2, you start your raised to the power 0, 1, 2, 3, 4, 5. Do you understand what I did? I first multiplied it and then I started raising it to the power from here 0 and then like that. We could have 10 numbers. I'll start from 0 at this other side. So now, anything multiplied by 1 is that thing. So what is 2 raised to the power of 5? 2 raised to the power of 5 is not the same as 2 multiplied by 5. It's simply 2 multiplied by 2, multiplied by 2, multiplied by 2, multiplied by 2. What do I mean by that? 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. 2 raised to the power of 5. So 2 multiplied by 2, 4. 4 multiplied by 2, 8. 8 multiplied by 2, 16. And 16 multiplied by 2, 32. All right. 32 plus, don't forget, 2 raised to the power of 4 is 16. All right. But there is a 0 here. There's a 0 around here. Anything multiplied by 0, even if it's a million, multiplied by 0 is going to give you 0. So I get my 0 here. And then another 0 is here, I get my 0. Don't stress yourself. And then the next one has a 1. It's not a 0, so you calculate it. So 2 raised to the power of 2 is what? 4. Thank you. Plus, and then there's a 0 here. Do not stress yourself. Just put a 0 there. Plus, now 1 is here, of course. 2 raised to the power of 0 is 1. Anything in the world raised to the power of 0. Don't confuse it with these ones, okay? This is anything raised to the power of 0 equals to 1. 100 raised to the power of 0 equals to 1. Do you understand that? So this guy raised to the power. Alright, so what do we have? 32 plus 4 plus 1. That's 32 plus 5, and that's 37. 37. So our final answer is 37 base 10. Do you understand that? So we'll go another round. Let's say, for instance, we have a number here, 111, right? Base 2. What is the first thing we'll do when you're converting to a base 10 system? You multiply each of them by 2. Each. 1 multiplied by 2 plus, you can do it horizontally. Do it horizontally. I'm doing it vertically so you can see me. Plus 1 multiplied by 2 plus 0 multiplied by 2 plus 1 multiplied by 2 plus 1 multiplied by 2 plus 1 multiplied by 2. Now that we have it like this, if you do it like this, you might get a bit confused because you're supposed to arrange it like this, you get? But we'll do it so that you can see what I'm doing. Hopefully, if I write it in a straight line horizontally, maybe you wouldn't be able to see it. So I go 0, 1, 2, 3, 4, and 5. All right. Then I start. 2 raised to the power of 5. We already established that. That is what? 32. Plus 2 raised to the power of 4. 2 times 2 times 2 times 2, and that is 16. All right. And 2 raised to the power of 3 is 8. But there's a 0 here. Everything turns to a 0. And then 2 raised to the power of 2, that's plus 4 plus 2 and plus 1 is here. 2 raised to the power of 0. Anything raised to the power of 0 gives you 1. 1 equals to 32 plus 16. That is 48. 48 plus 2, 50. And then everything we have here is what? 55 base 10. Do you understand? Okay, hopefully you'll be able to do all the numbers. Try your hands on a couple numbers from 7 to 10. Random numbers, 2 digits, 3 digits, and you'll be able to get it. And here you can try a number, your hands on a couple of numbers too, and get it. So I hope you've been able to learn 1 or 2 today. I'll see you again in my next video. Have a great day. Bye.